Okay, welcome back. This is video 2 for the Drivetrain design unit. Okay, so this one might be a little more note heavy, so get ready to write. So first off, we need to talk about some terminology. The first thing we have is the drive wheels. It's pretty simple. These are the wheels that are actually going to propel the robot. If you have any non-powered wheels, those would not be the drive wheels. Next thing we have is the turning point. Again, kind of common sense. This is the point around which the robot will turn. You'll see some diagrams of that. Now this next one might be new. This is turning scrub. This is the friction caused by the wheels moving sideways. Oftentimes you'll see a robot kind of jumping around as the scrub is affecting it. Okay, the next one is the zero turn radius. So this is where a robot will turn without moving forward. Some of you may have a lawnmower. I know I have a lawnmower that's a zero turn, and basically you can turn on a single point. And we have a chassis. This is simply the structure that holds the drivetrain and the rest of the robot's components together. Your chassis design plays a large part into how much scrub and how much turning torque your robot has. Okay, let's go into a little more detail. So the different types of drivetrains. The first one's called an Ackerman, and this is actually a car style. And I bet many of you didn't realize that your car's turning has a specific name. It's called the Ackerman. Now, what I want you to notice is that the turning point is really, really far away from the robot. So this robot, as it turns, is going to go all the way around that turning point. And that can be really, really annoying at times, to be honest. So, with the Ackerman style, all of the wheels will move in the same direction. And the turn is an arc. There are benefits. There's no scrub. So you do not have to worry about turning scrub with the Ackerman style. There's a drawback. It's not very maneuverable. Pretty sure I spelled that correct. But with the Ackerman style, there's a lot of turning and backing up and moving forward and turning and backing up. It's very, very inefficient for a timed match like our Vex. Okay, the next type is called a skid steer. If any of you have looked at a Bobcat or a bulldozer, those use a skid steer. So the way we define these is that the left and right sides will have independent motors. So they are independent of each other. Steering then is accomplished by varying speeds on the left or the right side. So, some benefits. You have zero turn, which means you have very high maneuverability. And you don't need to waste motors on steering. And you can make zero turns, you can make arcing turns. It's a very nice drivetrain. It's very quick as well, since it's so highly maneuverable. Now, there is a drawback. You can have scrub. Well, there's scrub sometimes. We'll talk about how to eliminate scrub with this type of system. And, obviously we get our zero turn. This gives us very precise positioning. And I think you've already seen this. It's the most popular. The the skid steer has a lot going for it when it comes to design. All right, the next type is a swerve drive. This one I think is a lot of fun. What sets this one apart is that each motor there's a motor placed on each wheel individually, and then each wheel gets independent steering. So there's one motor per wheel, and then independent steering for each wheel. You see these type of systems on a lot of robots we send to other planets, especially the ones we've sent to the moon and to Mars. All right, the next type is called a crab drive. In this one, it's kind of like a skid steer. So in the crab drive, we have two sets of skid steers, each pointing in a different direction. However, there's only one set touching the ground at a time. So this would be something where the left side drops down, picks up the robot, moves, and then lifts up, and the front and back side drops down and moves it around. So it's a very, very fast system. It makes very quick left and right motion, just like a crab, which is why we call it a crab drive. And then finally, we have the omnidirectional drive. So this is a drivetrain that can move in any direction at any given point. It does this by taking advantage of the omnidirectional wheels. So in this example up here, we would have a motor attached to each wheel. And then, we can move forward, we can move left and right, we can even move it at an angle, just depending upon how much power we give each wheel. And it makes for a very stable platform. What's nice about these is that there is no scrub. Also, you can use different configurations. I've got some different configurations posted here. The downside is that you need multiple motors. And sometimes you won't be using all of the motors that you have available. Some of the motors are turned off and they're not contributing to the robot. But sometimes you might not worry about that. All right, well, this concludes video 2.